everybody? Welcome back to another 3D Hangout. This is episode 173, Boxes, Buttons, and Spudger.
That's right, this week we're going to be looking at a Circuit Playground powered soundboard.
We'll take a look at some prototyping and some layer-by-layer CAD stuff.
And we'll be taking a look at USB Web, or Web USB, for Circuit Playground.
All this and more on, you guessed it, 3D Hangouts.
Excellent.
Whoops. And hello, welcome back everybody to another 3D Hangouts. My name is Noah Ruiz. I'm a designer here at Adafruit, and joining me every week is Mr. Pedro.
What's going on, everybody? I'm Pedro's Creative Tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right, this is where we combine 3D printing and DIY electronics to make inspirational project for maker folks like you. Thank you guys so much for joining us today. Just a quick programming note, you are watching 3D Hangouts. We're live every Wednesday at 11 a.m. Eastern Time on Facebook, YouTube, Periscope, Twitch, and YouTube. Did I say YouTube?
Yes.
Yeah, let's start off the show with some freebies for you. We got a coupon code for y'alls. If you want to put an order in today, you can get 10% off your order if you use the coupon code Big Mac.
That's right. Use Big Mac as coupon code during checkout. Get that 10% off.
Yeah, we also have some freebies, so if you spend more money, you get some free stuff. We still have these freebies going on. Go to adafruit.com/free to find out all the tiers. We are giving away some Adafruit Perma Protos, some Circuit Playground Expresses, which is actually the hero of this project, and a UPS truck. No, just kidding. You don't get the UPS truck, but you do get free ground shipping for orders over $100 and more. That means if you order a printer, you get free shipping on it.
Free shipping and 10% off.
Yeah, bad for us, good for you.
I think there is a 3D printable UPS truck on Thingiverse somewhere. I remember seeing. We also got free same day, not free, same.
That is not
free. Same day delivery.
You got to pay for this one, guys. This is same day delivery. That's hard to do.
Need some more coffee.
Okay, more coffee. We have Adafruit Daily. That's a newsletter. It's a daily newsletter. That's why it's called Adafruit Daily. You got to subscribe to this one yourself. So if you're not subscribed already and you want to, you can go to adafruitdaily.com. It's a separate site, separate from your account if you do have one with us. So you'll have to kind of pick and choose the type of newsletter you want. We have different categories. We have like wearables, we have 3D printing, CircuitPython, which is a new one, and biohacking and that sort of thing. We also have a product-focused newsletter. This is adafruit.com/newsletter. This one comes once a week. Again, separate from your account. You don't automatically get to stuff. You have to opt into it because doing that automatically is annoying. Discord, we're going to stop by the Discord chat room and take a look at what the community is working on. This is a place where we are available 24/7. We're there all day long. You can chat, get some project help, or just share some general things you're working on. Really quick, I want to say shout outs to everyone in the chat room. People in the chat room over here are hanging out with us. Thank you so much for joining us. Stuff with Kirby, shout out to you, sir. He is a moderator, so you don't mind him behave.
And he just posted the link to the UPS truck on Thingiverse.
He's fast, thank you. And he'll post some links and stuff to some things we're talking about. So shout out to Kirby. We also got Jim and Liz and Andrew.
Am I muted?
You are now unmuted.
I was muted?
Yes, you were. Thanks, Mattable, for pointing that out. Huge shout outs to everybody in the chat room.
Thank you.
Of course, Mattable. What's up, Kirby? We got Liz in the house, Jim, Andrew Murphy. Thank you all for joining.
Yeah, I'm hungry too. I want a Big Mac.
I know, I want a Big Mac now.
Yeah, so the Big Mac is, let's just jump into this week's project. So what is a Big Mac, right? So this is a Big Mac in the world of assistive technology. This is this is by a company called AbleNet, and what they do is they make assistive tech switches for the assistive tech community. So this is a button that kind of does one thing. You press it and it plays an audio sample. So this, you can record like a message and play it back by pushing this big button. This is really helpful for people that don't necessarily have the motor skills or the ability to actuate things and kind of communicate with the world. So this big button is easy to press, and it lets you communicate without actually having to, you know, use your lungs to say words and such. However, it's you'll see this trend that these things are very pricey. So you can see this thing costs $135 for essentially a button that plays an audio sample. So this was inspired by Bill Binko of AT Makers, and Bill Binko has reached out to us a couple of months ago now, and we've been kind of collaborating back and forth on different projects. He actually he kind of spearheaded the Feather Box project to kind of create a box that could be used for a lot of different things. So one of the other things we wanted to do was create a version of a DIY version of this Big Mac. So this was the code was developed by Lamar, and she really wanted this to be a CircuitPython powered project, because with CircuitPython it allows you to modify the code on different computers. So if you want to take this around to a different computer that doesn't have the Arduino IDE or doesn't have GC compiler, you can just plug it in and it shows up like a USB drive. You can look at the libraries that are in it. So it's like this portable platform that has all the libraries in it. It has Python. It's like portable Python. It's pretty amazing.
It's super amazing coming from not being able to do any of that. On Arduino, once you compiled your code, it's
stuck
lost.
there and you can't see it ever again. It's just kind of, if you take it to another computer, you can't really go and modify. You have to kind of start over again. So that's what's the power of CircuitPython. Was really why I wanted to make this project. So I guess we can take a look at it as the demo. I wasn't able to demo it last week because I was putting it together, but this is a big button. We call it the massive button, and we haven't really done too many projects with it, so this is kind of one of our first projects to do with it. We got a nice knob here for doing volume, but it also has a switch built in, so you can hear that click, and you can adjust the volume. Hopefully it's working. Do you think it's working?
All systems are fully operational.
Yeah, it's working pretty well. So on the side here, we have some speaker holes, and inside there is a speaker. This is a 3-watt speaker that's inside there, so that means we have an amplifier as well. And on the side here is a jack. This looks like an audio jack, and it is an audio jack, but it's not meant to play audio. The assistive tech community, well really the assistive switches, use a kind of a standard TRS jack is what it's called, for tip, ring, and slip, or sleeve. Yeah, tip, ring, and sleeve is what the terminology, whatever. So anyway, you can still use existing AT switches because they're expensive, right? So you can actually connect it in here and actuate it as well. So what's inside here, you can see it's glowing.
All systems are fully operational.
Well, inside the button is Circuit Playground. The Circuit Playground Express is inside the button. And what we'll do is we'll take a look at the learning guide, so you can see how we built this and all the parts that kind of make it work. So in the learning guide, we have all the parts listed out, and one thing I wanted to show you is we don't really talk about too much about cost, but with this one it kind of made sense to. So I put all the stuff in my shopping cart, and it all comes out to a total of $56.35. Obviously that might change with shipping and stuff like that, but it's definitely lower than sort of the Big Mac project that we're trying to replicate here. So it's definitely right. The price point I think is right on there. You could probably build 2 of them for the price of 1 of these. So that's pretty nice. It is a fairly big build. There's a lot of parts to it, so there's a lot of wiring and things. So that's why we put the guide together. So we walk you through all of the steps to build this, and of course some ancillary tools and stuff like that. Screws, just a handful of screws, not too bad. So let's talk about the circuit diagram. How's all the stuff wired together? This is really a good project that is a good example of how do you get audio out, right, from the Circuit Playground Express. You can totally do that. And there is a built-in speaker on the Circuit Playground Express. It's a little bit of a piezo, so it kind of makes like little bloops and blops. Not powerful enough to kind of fill the room with audio, so we're using our little mono amplifier here. This is a 2.5 watt Class D amplifier, so it's pretty decent. So that gets wired up into the Circuit Playground to adjust the volume and to turn off the circuit. We're using our new potentiometers that has a built-in switch. and with the switch, you can turn it on and off. You can basically cut the power from the battery. So it's really nice. And then the speaker gets wired into the amplifier. If you want to use like a 3-watt speaker or so, because the amplifier can do about like 2.5. And then for the button, we have the button wired up to one of the analog pins. It's A4 over here. And then we're also using that TRS jack to route into the same pinouts for actuating the little button. So that's pretty much the circuit. We also have this fritzing diagram. If you ever want to reuse or remix this thing, you can download the source file and modify the circuit diagram so you can reuse the parts that are used in there. We also have an Adafruit library for fritzing. Fritzing is an app that allows you to create these drawings. Well, not really drawings, just kind of create these wired connections. So it's really easy to click and drag to make these wired connections. So if you're ever working on a project and you want people to give them a reference of how to put together the circuit, using fritzing is a really powerful tool, and it's open source, I believe. So check that out.
And we have an extensive library of all of our components.
Yeah, and when you download the fritzing file, it'll include the parts so you can reuse them that way. Yeah, it's pretty big library. I actually just pick and choose, so I don't want everything. It's kind of massive. Let's talk about the software. It's the heart and soul of this project is CircuitPython, right? So I'm going to walk you through setting up the Adafruit Circuit Playground Express for CircuitPython. Now, the newer boards do come with it shipped, but if you have them, if you're one of the early developer versions, just making sure that we can get you to the latest build, latest firmware for CircuitPython. It's really straightforward. You just download, you download a file and you drop it onto the drive and it automatically flashes itself. It's just super convenient. And that's what really CircuitPython is about. Less code, more convenience, plus community. It's my little math thing. So the library bundle, we are working really hard to create libraries for CircuitPython. Every day and week we're coming out with new drivers for sensors, for motors, for all sorts of different things.
Which is a very good time to plug the CircuitPython chat. That happens every Monday at 2 p.m. Eastern Standard Time.
Is it 2 p.m.?
I think it's 2 p.m.
2 p.m. Eastern Time.
Mm-hmm. Definitely.
Yeah, it happens on the Discord chat, the Discord channel, rather. So if you want to check that out, go to our Discord link. That's discord.gg/Adafruit. And you can join in and sit in the call where we talk about the development and what people are working on. Very, very cool. Shout out to Scott for doing that. So talking about the CircuitPython library bundle, it comes with a ton of libraries. So you're going to download this one bundle that has all the libraries and then pick and choose the libraries that will work for this project. The ones that are required for this project, just 3 of them. We got the NeoPixel library. That's to control the NeoPixels that are on board the Circuit Playground. We have Adafruit HID library. Now you might think, well, why do you have that? There's a little secret to this project is that it also acts as a mouse. So if you plug this into USB, I kind of forgot to show that USB port. The USB port's actually right here. You might be wondering, well, if the Circuit Playground is embedded into the button, how do you get access to the USB? Well, you break it out and you route it through here and use a little USB breakout. We'll talk more about that in a little bit, but what I wanted to say was, what was I going to say? Why do you have the HID library? Because it can act as a mouse. So when you click on this, you can have it click a mouse. A computer, when you hook this up to a computer via USB, you can essentially control the mouse by clicking on this button. That's just kind of the starting point, really. This isn't like a fully fleshed out thing. I think what would be really awesome is that you could use the accelerometer, because that's a sensor that's built into the Circuit Playground, to control mouse movements. So you can kind of imagine somebody using this to click and to move around, maybe scroll. A lot of different things you can do with it, and this is just a starting point again from a code standpoint. But it has it has a bunch of sensors already in it, so I think that is really neat. So that's why we're using the USB HID library, and of course we're also using the Circuit Playground library just to kind of communicate a little bit easier. It just makes this so we can write less code, and it's a little bit more digestible and readable. So those are the libraries that you'll need. And uploading the code is as simple as creating a file and dropping it onto a USB drive. Definitely want to recommend using the Mu editor. That's something that's new, and we recommend using it because editing code in a regular text app is a little bit chunky, a little bit not the best. With the Mu editor, it has it's got nice indentation, syntax highlighting, that sort of stuff. as a newbie programmer, I wouldn't even call myself a programmer, I'm super noob over here. I was able to kind of come in here and add a little bit of flair to the code. Originally, Lamar wrote this so that the NeoPixels would just all turn on when you press the button. So what I did is I went to the Circuit Playground Express CircuitPython demo page, and I ripped out one of the NeoPixel animations and basically shoved it into the code. So it's really easy to come in here. If you don't know any code, I kind of don't. And I was able to kind of futz my way around here. In the top of the code, we're just kind of importing all the necessary libraries and stuff. Here's where you can change the audio wave file. So what type of wave file? This is it's a wave file. It's an audio file. That's the format. It's got to be a little bit special. It's a mono file, and it has to be cranked down to 22 kilohertz. So it's kind of like a mid-range quality audio. And that's just to kind of save on memory so we don't overload the Circuit Playground with playing a beefy wave file. So that's why we kind of crunch it down a little bit. And then we are defining where the button is connected to. So in this case, it's connected to pin A4. I'm telling it it's an input. I'm telling it to pull up. Here we're telling the brightness of the NeoPixels to be half, which is kind of redundant because we change it over here where we're defining the NeoPixel object. We're saying we have 10 of them. We're saying we want full brightness, but that doesn't really matter because, or at least the brightness, because this is where we're defining the circle animation. It's called simple circle. We have two colors defined, which is a bit of a purple and a black color. So it'll cycle through from purple to black. In my version, I have it going orange. So that's easy to change. You can use web hex values, or you can use the RGB values here. That's what's cool about Python is you can kind of play around with different values. It doesn't have to be one way or the other. And then we're doing some range stuff. So saying certain pixels in this range, we want them to be turning off and on. And that's what kind of creates the animation. This, while true, if the button is If not the button value, we are creating the audio object to say we want audio out, we want it to be on the speaker, on board the speaker, and we want to open this audio file, and then we want to play the audio. So it's really easy to read it, and it kind of makes sense. So while the audio is playing, we are also running that NeoPixel animation. Whew, so that's pretty cool. And again, the audio wave file, if you want to create your own samples and stuff, you'll need to convert it as a wave file, so it doesn't currently support MP3s, but that's fine because we have online editors and stuff to convert that for you. So that's just a kind of a nutshell. Hopefully I explained that well as a newbie programmer. I don't know what I'm talking about. Also, we have the mouse thing here, so you can uncomment this code. Currently I have it uncommented because if you uncomment the mouse click function, it will only work via USB because it needs to connect to a computer in order for this to function. If you're using the mouse click feature. So there you go. Hopefully that made sense. Let me guys know if I explained that correctly. You can always revisit that. You can always get help too from the CircuitPython channel in the Discord chat room. Let's talk about the 3D printing stuff. It's just 3 parts. Now they're kind of big. It's a big box, big lid. I also had to create a custom housing for the button, so we had to put that together. All the STLs are on Thingiverse. I'll put them on the other sites a little bit later. So our standard settings here is what we like to use. So line layer width and some extrusion temperatures, nice speed and whatnot. Not much to talk about there. What I do want to say is that I worked on designing a lot of the components before actually designing Enclosure, and I think it's important to kind of do that. We're slowly working towards creating this big library of parts that Adafruit carries so that we can hopefully give these all away as step files within the couple months to come. So we're just kind of building these up. Still got to clean them up a little bit. I'm starting to do more details, more colors and things like that, just to kind of make it look really nice. So you can see that here with the PAM8302 and the potentiometer. So if you want to download these components, you can download the source file, which will contain all these things, and you can kind of extract them out yourself. So it's really nice. And of course, it's all open. Well, the design is open to download, so you can download it in many different formats, which is really nice because it's parametric as well, and you can quickly build on top of it, or break it apart if you want to. So that's cool. Those are some freebies for y'all if you are into designing stuff. Onto the build. You want to talk onto the build?
Let's move on to the build.
All right, so this is the arcade button. It's a lot of pieces. So here's what it looks like when you disassemble the button, and it even breaks down even more. So I'll kind of walk you through with these animated GIFs and how to disassemble the button without breaking it, because it's really important to kind of disassemble it without cracking any of the pieces.
Yeah, it's great to reuse parts, but not so great when you have to carefully disassemble it.
Yeah, thankfully though it's designed for that in mind, and the plastic is very durable. The white housing is, I think it's a HDPE, it's a high density plastic. And one of the things that, one of the tools rather that we carry and we really like using is called a Spudger, or a Spudger. A Spudger allows you to, is a prying tool, lets you basically get into the edges between things so you can open stuff really quickly. So let's do a little demo of the Spudger. This is a little $5 tool. It's made out of stainless steel, and the tips are tapered and optimized for wedging into things so you can break it apart. Let's go ahead and try it out. I want to try to get rid of this dome. So this dome is a little bit hard to get off of this button, but you could use this edge here to kind of take it off. Hopefully I can do it without breaking it. There you go. So there is the Spudger. I just kind of pop this out. There's a little ring here. This ring is what kind of grasps onto this outer lip here. This cover comes off. This is an optional thing whether you want to use it or not. It's up to you. I really like using it because it diffuses the LEDs nicely.
All systems are fully operational.
However, without it, it looks pretty neat too. It looks kind of like a brain. You don't need the cover. This white housing can stay in there. And
All systems are fully operational.
let's turn him off so I can actually push this in. Let's see if I can do it without breaking it. Let me see here. So I do say in the guide that you definitely need to give it a good firm click in there.
Got some tight tolerances.
Yeah, so it's definitely rough. You saw how hard I pushed it in and nothing broke. So let's turn it back on. Are you still working?
All systems are fully operational.
I'm gonna keep doing that joke. So you get the option to, expose the circuit playground or not. Obviously you want to keep the dome because that's where you actuate it.
Operational.
And there's nothing really holding the circuit playground in there other than the wiring. So you could
Fully operational.
you could hot glue it down or whatnot. I didn't think I needed to because the wires are pretty taut, so it keeps it in place. So again, you can take this out if you want to. Spudger tool is what you want to use for disassembling these type of things. So there you go. Back over to the guide. The micro switch has its own assembly. It has its own pieces and stuff. So in order to work with this, you kind of need to get rid of, well, you don't have to. You could keep the LED, but it has a built-in LED housing, and there's these two metal terminals that are kind of routing to the LED. So all this stuff comes together fairly nicely. So I have a little GIF here of showing you how to take that out of the housing. And from there, when designing the thing, we really had to think about what's the best way to embed the circuit playground. And the only way to kind of do it in this format is to create holes in the white button housing. So I had to create these holes. Fortunately, the black housing already had holes in it. So I was like, okay, cool. I could just use those as reference. And then I'm going to route all of my wired connections through those holes. So you have to create some holes. If you never drilled into plastic, you might want to use a scrap piece of wood underneath it so you don't drill into your work surface like this here. I used I used the power tool here. This is a impact drill. Recently picked one up because we had these older drills, and now I got a nice impact drill, and used a 1/4 or a 1/4 inch drill bit because it's nice and chunky. Kind of tried to make it more slots than just a single hole because the wires kind of get thick, and because there's a lot of them, so you kind of want some decent holes. So that's kind of the disassembly of the button and creating those holes. Obviously the words walk you through more detail. So in order to get access to the circuit playground, once it's embedded, you can actually see inside the circuit playground here is that there's a USB. See that micro USB? I had to DIY my own micro USB connector. So we sell these DIY micro. Oh, man, I can't get that thing to focus. We will focus. So you can see the USB. Gosh, there it is. So you can see the USB, the male USB connector is pretty tight in there, and then there's a JST connector right there. But this is how we're able to route the USB out through there, so we can still program it and power it through this guy over here, which is a little breakout. So let's jump back into the guide and take a look at that. You need 5 wired connections to do full proper USB power and data. So I walk you through how to do that. It's pretty difficult to solder to these very tiny little pads on the micro USB connector. So you probably want to use a fine-tipped soldering iron. I'm using kind of a marker tip type, and that one is you can do it, but you gotta be very careful. I almost destroyed one by melting the plastic, so just be careful and probably want to use a fine-tipped soldering iron. If this is your first soldering project, you might want to practice a little bit before doing something like this. Just saying. Wiring up the amplifier.
All right, finally, moving on to the music stuff that Olinsky wants to know about.
What is it?
How is this Circuit Playground getting audio?
How's it getting audio?
Mm-hmm. How are we pushing audio out?
How do you push audio out? Right. So this audio amplifier we're basically wiring the positive audio input to I forget which pin out, but it's in here in the circuit diagram. So it's going into A0, which can do audio out and PWM. So that's coming into this potentiometer, and that's going to control the volume of this guy here, which is the audio positive terminal here for audio input. This is where the audio input's going like that.
And quick question, can he operate this without an amplifier? Like just hooking up a speaker?
Yes, you can. Without, if you don't wire up anything to the A0 pin, it'll just play out of this guy here.
Oh, the included piezo?
Yeah, you can see that the piezo's in this area, and it has the same pinout labeling. So it says A0, analog 0. Well, that's analog 0 too. So we're routing that potentiometer just to control the volume. And to power the amplifier, we're using the voltage out. So that's a pin here on the circuit playground. And of course, you want to also connect to ground, so you can close the circuit there. So that's how you're getting audio out.
So do you actually need the amplifier? Could you just hook up
the speaker? If you want
loudness,
yeah. If you just want the speaker, well, you need extra circuitry to pump out more power. So that's why we're using the amplifier, because it's got that Class D chip on there. But by default, it's just a piezo, and it's not very loud at all. So that's why we have this sort of configuration here. So yeah. And where were we? On the amplifier, yeah. So that's kind of how to wire up the amplifier. A little bit weird that you have to tie the ground to the audio. You have to tie a ground to itself right here. The audio input needs a ground, so you just kind of tie that to ground. This is because it's a mono speaker, and you don't need stereo. So I kind of walk you through that. Connecting the speaker is pretty straightforward. Our little speakers come with these JST connectors and a pretty long wire. That could be good for some projects. For this one, we didn't need it so long, so we just kind of trimmed it down and soldered directly to the audio output pins on the amplifier. Now, one thing about this is that the audio amplifier does come with a screw block terminal. I like screw block terminals. However, it kind of is not, I don't recommend, don't use it on this project, because if you do, then you won't be able to secure the amplifier to the enclosure, because the mounting holes will be blocked by the screw block terminal. I actually did that before starting the project, and then when I was ready to install, I was like, oh crap, I can't put these screws in because the screw heads are in the way. So just a lesson there is think through before just soldering stuff in. I was like, oh yeah, screw block terminal will totally be easier. It made it harder. Let's talk about the pot switch, because it is a part of the audio. So this is a special pot switch. I'm calling it a pot switch because it has a switch built in. So it's a potentiometer, but when you go all the way low, it has that clicking sound. So what's kind of neat about it is, especially with audio stuff, is when you turn on something, you don't want the full volume on because it might kind of create some noise. So this one ensures that you can turn it on and gradually turn up the volume, because you have to turn it on that way. This just needs 3 wires. It gets hooked up to one of the ground wires and gets split in line with the audio input for the amplifier. There's a little nub on the side of these potentiometers, which you can get rid of because it will kind of stop it from being panel mounted. I don't know why that's there, but it's probably for like a registration key or something for enclosures, but mine doesn't have that, so just rip it off. It's fairly easy to do it. And that's what it looks like with the wired potentiometer. Definitely recommend using a lot of heat shrink tubing, because the first prototype I made, I didn't use any heat shrink tubing, and it's kind of a mess with the wiring, so these heat shrink tubings will keep the wires bundled together. In order to do power, I wanted to use this JST extension cable, and these are really nice and handy because you can basically wire a switch in line with this. So it's basically just a male and a female connector on one end and the other end, and you can wire this to the switch on the bottom of the potentiometer. You want to use the positive wire, so that's the only thing you're cutting. You're cutting the power through that connection. And then the ground wires get tied together to kind of complete that circuit. So you can pop in a battery on one end, and the other end, which is the male connector, gets plugged in directly to the Circuit Playground, because Circuit Playground has a built-in JST plug for power. Let's talk about the button itself. Again, the button can be broken down even more, so you kind of have to disassemble it just to kind of work with it a little bit easier. There's 2 giant terminals on the micro switch, which is the button. You need some more wires for it. They're fairly chunky. We have some quick disconnects I really wanted to use, but these are too big, and their quick disconnects are a little bit smaller, so they're a little bit bigger, so I had to flood it with some solder here to connect it. And that's what it looks like. I'm going to put the housing back in. Talk about the TRS jack. I haven't really wired one of these guys yet, so I had to kind of look up how to wire these. And one of the tips I found was, per Lamar's circuit diagram, she said two of the legs have to be soldered together. So instead of using a wire, I figured, yeah, a little bit easier way is I broke off a piece of header pin, and then I slipped it through the little holes to join the two terminals together. So this is the tip and the ring. The sleeve is basically ground, which is the bigger leg that's sticking out. So kind of a neat tip. You could use header pins to make these bridges connections. Just gotta make sure you apply a little bit of solder to them to make sure it's nice and welded. And be careful with the plastic bits. I ended up melting a little bit of the plastic here, but this is what it looks like. Yeah, wired up. So it's just 2 wired connections, and then a header pin to bridge those 2 pins. All right, here's what it looks like with everything wired up outside of the Circuit Playground. This is a little bit of a weird order that you have to do these. You kind of have to wire up all the components and then install them, and then one of the last things is to wire up the Circuit Playground, just because it's embedded in this kind of way. So that's what everything looks like. Again, heat shrink tubing, so much heat shrink tubing. It really keeps things nice and tidy. It may look like a mess here, but this is the cleanest you can kind of get it. Okay, so and then start assembling the box. I had to make my own button housing for the bottom there, just because I didn't want to drill holes into the black housing that it comes with, because it's a rather thick piece of plastic, so I designed my own little button housing for it. The way the button is secured to the box is with I guess it's like a threaded ring, and that threaded ring gets screwed onto the stem of the black button housing, and that's what panel mounts it to the box. Of course, you want to make sure the holes are lined up, because we will be using those holes to route all the wiring. So when putting this together, I had to think about, well, what's the best order when building this? So when you're creating a project, you really want to think about the best order of things, and as you're building it, you might kind of step back and be like, oh, okay, well, I should have put that in first. So for this one, the speaker ended up being the easiest thing to install first. So the way the speaker is installed is through these little clips on the inside. Hold the tabs, because the way the speaker enclosure is designed, it has like these kind of mounting tabs. So those get fitted fine, but then I needed to create some standoffs to hold the other end of the tab. So I'm using some M3 screws to secure those tabs to the side wall of the box. One thing about the amplifier is it's a little bit, the mounting holes are a little bit tighter than our regular breakout boards. So what I recommend is getting a M25 tapping tool to create the threads inside those mounting holes, because again, they're really tight. You could use an M25 screw to create those threads, but it's a little annoying because they're not necessarily sharp, and the tapping tool has the right sharp edges, and it has like a little groove to kind of break away the material to create a proper thread. So I highly recommend doing that. And once you do, it's the threading, inserting a screw is like really nice and buttery, right? So that gets fastened to the inside of the box here with these little standoffs that are built into it. Installing the potentiometer is really easy. It's just a hole, nothing special about it. The potentiometers, most potentiometers come with a washer and a hex nut. The hardware necessary to kind of panel mount it here. So I just pop that in and thread the ring. And from there, it's time to start it's threading these wires through these holes. Is a little bit challenging if you don't have heat shrink tubing, so they're all bundled together because the tips and stuff might not all fit through. So that's why I'm using a lot of heat shrink tubing. The JST male connector just barely fits through the hole. You have to kind of pop it in, but that works well. That can pop in. The TRS jack is also panel mounted. Comes with the hardware already for you, so you just pop it in there from the inside and then add the ring on the outside. Threading some more wires. As you can see, that I have four holes actually all get used up, so it's a nice kind of order here. Threading some more. Here's what it looks like on the bottom with all the wires coming in to those holes. I'm kind of grouping them together here since the button and the TRS jack kind of do the same thing functionality wise. So I'm also using the same colored wires too, so I can tell them apart. The weird thing about the micro USB cable is it's the only thing that gets wired from the top instead of the inside like all the other ones, because the micro USB connector will not fit through those holes unless you make them really big. So you could do that or just do it this way where you route it from the top. And that's what it looks like with all the wires ready to install onto the Circuit Playground. So let's go to that one. So a couple of options you could do when wiring the Circuit Playground. I opted in to wire it on the bottom of the board, which is a little bit, definitely take note because there aren't any labels for the pins. So once you flip it, it's inverted, so you're gonna have to kind of flip back and forth or just take a visual note of where your pins need to be. So it's fairly easy to solder onto the pads. It's really big pads, so you can flood it with solder if you want. And then wiring it up, the wires are oriented this way to kind of keep it nice and tidy. They're a little bit more concealed this way instead of, coming out on the outside of it like you typically would do. Either way, you want to use a good amount of solder and stuff to make a nice, good connection. Then one of the last things to do, well, not last thing to do, but plugging in the micro USB and the power here is the next things. And then you want to double check the underside again. This is where a little bit of more planning could have happened a little bit better on my part. So what ended up happening is I threaded the wires could be threaded to different holes, obviously, and depending on whichever one you use, it may or may not be in the optimal orientation for connecting to the Circuit Playground. So you can see I'm looking at the underside, but once I flip it over, all the wires are kind of crossing with each other. So you could unsolder them and rethread them, but it's kind of a pain. So definitely using longer wires is a good thing because you have enough wires to kind of play around with. There's plenty of room in the box for excess wires. And then one of the last things to wire up is the USB breakout board. So this is just a tiny little breakout board with 2 mounting points and all the pins for creating the USB data and power. So that's what those are. And the reason why we're wiring it last because we can't really thread it through those holes. It's a little bit too big to thread through the holes, so that's why we thread the wire and then solder up to the breakout. And the bottom cover is where the micro USB breakout is attached to and mounted to, and there's a little cutout there lined up nicely with the edge of the bottom there. And then of course you want to use a battery pack if you do want this to be portable. Lamar recommended using a AA pack because they're safer, they're less dangerous, and they're easier to come by. I didn't have that one, so I just threw in my LiPo because I have so many LiPos. So it's up to you, but there's plenty of room in the box for all sorts of different battery packs, whether you're using a LiPo cell or a AA battery pack. This should all fit in there as I designed around a AA pack in CAD. And you know, the bottom has the snap fit features, so it locks into the case. You get a really nice alignment with the USB connector there. It's got a nice hole there. Installing a knob is optional. You can install knobs, or you can 3D print your own knobs. I got a great guide here on how to make knobs from Tommy, who runs Oskitone. I actually don't have the page here, but it's on his website, and I was taking a look at it. I'm actually going to share that, how to make OpenSCAD designs for these knobs here, and kind of design considerations for different types of potentiometer knobs and stuff. So pretty neat. Good little side note there. And then the last thing to do, of course, like I showed you, is to install, whether or not you want to install the light diffuser cover and installing the dome. And that's the whole guide. We just walked through the whole guide. But stepping it through it really kind of makes you think all the little design considerations and stuff. One of the things that I wanted to talk about was why we didn't use Arduino, or why we didn't use the Adafruit sound effects boards. Those audio sound effects boards that we make are really nice, but they only do one thing. They play audio. They're not a microcontroller to control neopixels, for example. Circuit Playground does it all, so it can play the audio, it can have this, you can have the neopixels light up, and it has all these sensors in it. So that's why we chose to do Circuit Playground, not just an audio sound effects board.
Yeah, a lot of cool things you can add on, especially for assistive tech, is have the light meter play a different sound when it detects it's, you know, dark, or if for whatever reason, you know, they fall or it falls off the desk, it could say, you know, help me.
You could do some tap detection and orientation detection.
So there's lots of different inputs you could actually add on to this, in addition to the sample code that's up there right now.
You could shake it and it does something else.
Yeah. So for, I don't know, like thresholds of, you know, like something being shaken, or like moving somewhere, something where like a beam crosses or something like that. There's lots of...
yeah, there's an IR light right on there, so you can control it via IR as well. There's so many things on it. Temperature sensor.
Yeah, if it gets too cold in the room,
it has a microphone in it.
Alert someone.
Yeah. It has a switch and buttons, of course. So a lot of great stuff. Again, it's a starting point for a much bigger project, I think, that you can make. So
yeah, someone in the Discord, Treehouse Cookie, is saying that they're looking at building this exact same thing, but wearable.
Oh wow,
really cool.
Yeah, that's a little bit more challenging, but definitely doable.
And then Andrew Murphy in the chat room is also interested in making this as well. The file for the box is STL, step.
Yeah, you can download it in any format.
Very,
what I really like about
formats.
Fusion is they have quite a nice web UI, and that you can now modify designs within the browser without having to download anything. So you go to 3D printing, click on the source file right here, this link. It says download Fusion 360 source.
It won't actually download it. It'll actually take you to a web view of the project, where you can then download all the files in whatever format you need it to. So if you go over to the drop down where it says download, you can see all of the
Inventor, SketchUp,
extensive amounts of file formats.
SAT, IGS. And I really like their kind of web display. You can like explode the model and see all the different pieces break out. You can even see the compression spring I drew in there. A lot of detail in these components. Again, you can reuse these components as you like. They're as accurate as I could get them, at least for the moment, the mounting points. So some good bit amount of work there. So again, you can download the source here. Again, Fusion 360 Archive, if you want to use it in Fusion 360. It also comes with a parametric timeline, so you can see in step through the design and see the order of operations, sort of. So that's the design there. Getting, again, working towards a sort of a library of 3D models that we'll be able to share. Right now we don't have that, just a little silly, but we're working. We just want to make these a little bit better, you know, have the right, you know, name all the sketches and have a little bit more texture to the things. So we're working on that. Any other cool questions? I'm going to catch up with the chat room because I'm curious.
One on...
Why Python? Is that one? What's
Where is that one?
Yeah, we talked a little about why we used Python, CircuitPython rather, because it's easily editable. You can bring this to a different operating. You can bring this to Windows. You can bring this to a Mac. You bring this to Linux. You can always edit the code because when you load it in as a USB drive, you can modify the code right there. Library is there with you, so it's really cool.
And you're saying yes, you should be able to get STL files for using FreeCAD.
Yeah.
Comment from Liz saying thanks, huge lifesaver. Actually, I think Lamar and Scott wrote the library for this.
Dan as well. He
Dan
originally spearheaded the HID library,
yes,
which is
yes.
what a lot of our projects are now starting to use. Is the human interface device library, the USB device library. So we can do key commands. We can do mouse events now. So we'll come out with more and more projects. Last week's project is kind of similar, is using the HID library to make different macros and commands.
And again, big deal getting audio out of a Circuit Player and Express, the 2 MB of flash on there. I think in the chat room too, somebody was saying that they were going to wire up an additional flash storage to add more audio files.
Yeah, imagine an SD card slot. Imagine that, like somewhere down here, you can load in some samples, play back a bunch of different samples, have it randomized, so every time you hit it, play something random. I'd love to see something like that. It's really cool. Really cool ideas.
P. Curie in a Hurry, I love that name, saying, yeah, they've been programming Python since 2003, and the idea of getting a REPL just by plugging in USB cable is kind of fascinating, kind of scary. I am still like in awe. Like, I remember when we first heard Scott talking about having this load up as a USB, and that right there was just the moment.
Like, oh,
what? That would be amazing, because we had just come with a lot of our projects, especially now, you know, being like almost 5 years old now.
Yeah.
We can't get that code anymore. We've lost the sketches for it, or it's just not compatible with it anymore, and it would be so great to be able to look at it at least to see
what's in there.
At least transfer that over to another component or board, since you know, for whatever reason, you know, sometimes boards die or they get fried.
Yeah.
And the code that we had on there is just lost forever. So huge deal, and being able to plug it in,
convenience of
have
less
it load
code and libraries is really nice. So yeah, that's the project, and again, it's pretty good. About $56 to build this. Definitely a lot better than the
Big Mac.
The Big Mac. I wasn't allowed to call it that for legal reasons, but we can have it be the coupon code. So shout out to AbleNet for the Big Mac. And Bill Binko. Talk about Bill Binko real quick. Bill Binko's awesome. Let me talk about, he recently had a really big event, I think a couple weeks ago, and this was a huge hit. So he had a lot of students, robotics teams from Florida and even from Indiana, all came down here in Florida. This annual ATIA annual conference. So kids came and they learned how to solder. They learned how to adapt toys. Adapting toys is the term for hacking toys so that they're more accessible to folks that might not necessarily have fine motor control. They might be in a wheelchair. So this is really, really nice. Making custom assistive tech solutions using tech, using DIY stuff, even non-DIY stuff like Instamorph. Really nice, incredible energy. So these are the robotics teams that came by, and there's a lot of nice photos and stuff here. One of the things that I think was really cool was this massive Power Wheels adapted a power wheel with a big button. Does that big button look familiar to you? Like it's these big buttons, man. They're really huge with the AT community. So you got these kids and some of these mentors like teaching kids how to, you know, work a drill and solder connections and hack toys for the good of humanity. Some very cool stuff going on. Shout out to Big Oak Binko for doing some awesome work, and they had a great time here, and just wanted to share that with you guys. So shout out to AT Makers and all of the awesome people that are helping other people out too.
Moving on to this week's prototyping.
Yep, so we did this week's project, and what are we prototyping? Well, I wanted to revisit the last week's project a little bit. So I put together a little update to it. It's more for aesthetics and ergonomics. So we designed a little bit of a bigger bottom here so it flanges out, and I took the opportunity to make a layer by layer tutorial. That's where I create step-by-step screencasts of using Fusion 360. So I put this together in like 7 minutes because I walk through every step, and it's really dense too. So it, as far as ergonomics, your hands can hold on to it, and you can turn it like that, and it's got more weight to it. It just feels a little bit better with a bigger bottom. This is a little bit top heavy, so it won't topple over. And that was really it. So if you want to check out the layer by layer, I have that in the layer by layer playlist that's in the YouTube channel, in the Adafruit YouTube channel. So check that out. That's really all I got to say about that one. We're working on some other things. How much time do we have? Wow, we are way... This project is a pretty big project, so
this one took a while.
This one took a while.
So much so that we're going to have to do a filler project for next week.
Yeah. Yeah, something a little bit more easier, less wires. One of the last things I want to talk about is kind of user testing your projects to see how intuitive they are, right? So we got a hold of our young intern, and we thought it'd be a neat experiment to let him see how intuitive this project is. Can he turn it on? Does he know what it does? So we let our little young intern, he's 5 years old. Now let's see what he does here. Spot on, he uses his foot to actuate it. And then he starts playing with the knob, and then he hears a click, right? Pushes the button and realizes, hey, it's not working. Well, let me turn it the other way, hear the click, and it's working. So without telling him any instructions, showing him anything, he learned how to use it right away.
Hey, look, it works with your foot too.
That's kind of what it's for, yeah. It's a big button, why not use your foot? So that's really nice to see a 5-year-old can intuitively turn it on and understands how it works and how to turn it off as well. It's pretty cool. That's our young intern, by the way. Ooh, D&D.
Again, younger and younger.
Yeah.
All right, moving on to this week's shop talk.
Yeah, let me situate my notes here.
This week,
real quick, Desk of Lady 8 is back. They did a really awesome stream last night. We got a close look at USB, web USB, which allows you to program Circuit Playground through Make Code.
Amazing.
Without having to flash the firmware. You just plug it in and it can upload code directly to it because you have web USB. It's a new API that works with Chrome. Check out the full stream from last night. It was a doozy. Also got an insight look at developing a new robot that Lamar will be working on, which is very exciting.
Very cool.
Okay, let's
show some demos using a Nexus tablet to actually
so you can use, the goal is to use like an old burner Android device so that you can use kind of older, cheaper devices. Yeah, we just got a FedEx delivery. That's always fun. Other thing I want to talk about was the Spudger tool, which we already showed. So that's cool. But this thing here is what we're going to talk about next. So this was the time-lapse pizzas here. I wish. That was not pizza. It's our tag, card tag. All right, well, let's take a look at the time-lapse Tuesday video in case y'all missed it. We'd love doing time-lapses every week. We try to do it once a week. It's a quick 1-minute video of just 3D printing the time-lapse. This is printed on an Ultimaker 3, dual extruded with 2 different colors. Because
so I wanted to test out the new CURA 3.2's tree support material, and it turned out so good that I didn't want to remove it because it looks like arteries and veins on the heart.
Yeah, did y'all know that? The blue stuff is not a part of the design. The blue stuff is supposed to be breakaway material that you throw away.
Yeah.
But because it's so artistically organic and looks nice, it kind of adds to the design, and it looks like arteries. And it holds up the design, obviously, too. Support material is what's necessary to create these overhang features so that the geometry isn't all sloping and printing in the air. So it's a new thing. It's a new type of support material.
It's actually not so new.
It's
Mesh
not.
Mixer has had this for quite a while. You're able to do a lot more flexibility inside that, but just being able to hit a check, just tick a box to enable it and just adjust some of the material, the material settings for it, turned out really good. And correct me if I'm wrong, but inside of Mesh Mixer, the tree support materials for that actually does like infill on these. The CURA version of this, it's completely hollow. It's like one shell, so it's minimal material being used on it.
That's amazing that it's just a shell. So
It's
less
just a
material,
shell.
less time. It's pretty nice.
And it's so clean. I am
You're pretty impressed?
so amazed with how
Let's get
good
closer
this was
there.
able to...
There you go. Look at
Especially
that.
on,
It's
like-
not even touching the material. It's not fused to it. It's to kind of make it so that there's a distance. There's like an air gap,
Yeah.
from the supports touching the surface of the
And
model.
this was all default settings as well.
Yeah, it's pretty nice. So let's take a look at CURA 3.2. They have a blog post about it.
It's so good that I've not...
We've been
used
using
Simplify 3D
CURA
for
a
while.
lot. Now, Simplify 3D is a paid software for slicing. You can do advanced things like custom placement for support
Yeah.
material,
Which I
custom
believe
jobs.
they're going to be adding that soon, because that's the only thing that's left to add.
Yeah. CURA is from Ultimaker, but it's open. It's open source.
It's
A
actually
lot
what
of the printer manufacturers kind of make their own version of CURA, kind of slap their name on it, tweak it a little bit.
Is this updated? Because they just released 3.2.1 this morning. A couple little bug fixes on that.
See if they wrote a blog post about it. Nope.
Where did I see that?
It's just
I could
blog
have swore it
post.
was a blog post. Yeah, there it is. 3.2.1 now available. And this works with a large variety of printers. I was able to import my profiles for the Type A machine, and it is printing a lot more better than it was with Simplify.
So let's take a look at some of the oh man, we're running out of time. Holy crap.
Oh, wow. Okay, yeah.
Well, anyway, check out the
definitely
blog
it out.
post. Very
Did
fun.
an excellent job. Really good Valentine's print that you can do. And of course, I want to give a shout out to the old school reigning champ of 3D printed Valentine gifts, the heart gear from Emmett.
Who's Emmett? Emmett was a rock star when the Thingiverse started really kicking off in 2012. He was coming out with a ton of amazing mechanical designs. This is a heart-shaped gear, planetary. Was it planetary gear?
I think it was planetary, yeah.
Yeah, so you can rotate this heart until it breaks apart and then comes out. It's not printed. They're printed in individual pieces. It's not printed in place. And it's printed in ABS on a MakerBot Rep 2 or Rep 1
Yeah,
back in
this
the
is
day.
so old.
Yeah, but it still looks brand new. It's ABS. Anyway, back to this heart. There's a lot of hearts this day. This is a new piece of software that we were playing around with. It's called Victory. Victory, I think is what you call it. And it's amazing. Really interesting user interface. This is a web-based CAD software. So I'm on a website. It's called Vectory.com. I'll have it linked below. And what's cool about this software is it kind of guides you through tutorial step-by-step on how to create a model. So what that does is it lets you understand and play with the interface before actually designing a project in here. So it's pretty neat. It just logged in with whatever account. You can log in with Facebook or create your own account. So I put together this heart, very timely heart, and I turned it into this really smooth model here. So they walk you through tutorial-wise how to design this thing. And all the tools, how to use the tools, and there's like levels here, help center. It's pretty nice. It's pretty intuitive. I like it. So just shout out to that. Also, I made it hard a couple years ago using some interesting techniques of color swapping and using infill patterns to create kind of these free patterns without having to draw them individually. So this is just infill patterns, all the triangles.
Yeah, another technique you used too was disabling the top or bottom layer, I believe, to get that infill.
Just printing it with clear material first and then switching over to red so you can really see that stuff pop. It's just a snap fit enclosure box. So if you want to make a box or something that's pretty, you can use different colors. Shout out to Tommy, who runs Oskitone. He's the maker behind the OK Synth. We are building it. So we 3D printed the top case, the top cover, the bottom cover, and the keys, which are printed with color swap techniques. So you can print white and then black on top for the keys. They're using Cavalier hinges, so they're all printed in place, and it's a really thin layer. There's like a bar, a support bar, and then there's a counter. We'll talk about it more.
We'll talk about it next week. I think we're actually going to just turn this into a project. Just a quick
project video, yeah.
Since we are out of time in terms of finishing bigger projects, so we'll take a look at this next week.
Yeah, it's a challenging print because it's big. Any type of big project, it's kind of challenging to print on with a lot of surface area. It tends to warp and stuff. So we're working through that. All right. Well, we're done, man. We gotta go.
It's time to eat.
Okay.
Thank you all for joining.
I really wanted to share people's projects. Really quick. Shout out to Liz Clark from Blitz City DIY. Let's try to get her to 3,000. She's at 22,900. So please subscribe if you haven't already. She does a project video every week. Lovely produced, lovely explained. She's starting to do live streaming as well. So thank you so much for sharing your work with us, Liz, and keep it up, man.
Cool.
Yeah. So that's probably the last thing I'll say. And coupon code. Where's the coupon code? There's the coupon code.
Expires at 11:59 p.m. tonight. There's also going to be another coupon code tomorrow if you join John Park's
There's going to be one tonight. Don't forget, tonight, come on the show and tell, win some free stuff. If you call in to Ask an Engineer, you get the pleasure of talking to Miss Lady Ada herself and potentially winning some new products. So check that out. That is, of course, tonight at 8 p.m. Eastern Time on the YouTube channel and the other social networks. And the show and tell is there as well, so come on to the show and tell. We'll be there hanging out. What else do we have? John Park is tomorrow at 3 p.m. Somewhere. 3 p.m. Maybe 4 p.m.
You'll see tweets about it, and I think he does a blog post on it too, but definitely check out.
I'll be in the chat room moderating.
Yep,
I was there last week.
Always listening while working on...
Our power went out. We got new battery backups. All right, we got to get out of here, guys. I'm sorry. Thank you guys so much for joining us. Really appreciate you guys tuning in. Don't forget, we do the show every Wednesday at 11 a.m. We try to keep it under an hour long, sometimes a little bit more, but...
So don't forget to follow Adafruit on Instagram. We're posting a lot of secret behind-the-scene things there that we don't post anywhere else.
Mm-hmm.
So,
that Blinka character is looking really, really fun.
Nice. Some of new puppets that'll be joining the Circuit
Playground
characters.
Show. Yeah. Thank you guys so much for joining us. And don't forget to make a great day.
See you guys.